Hey, welcome to Doing Too Much with Mr. Breland. Today we're going to work on sequences. The homework was 569 and 570, the even-numbered problems only. Corresponding odd-numbered problems are going to be worked in this video. So let's start with the examples from numbers 7 through 13. First, these say, find the first 6 terms of each sequence. These directions mean that we're going to evaluate the explicit formula for the sequence for the values of n. We're going to find values n equals 1 through 6, and we're going to write that as an ordered list or a set. Alright, so we're going to substitute values for n and compute values for the term. Your answer should look like a set of numbers. Let's go. Our first example, we're going to start by plugging in 1 for n, and then we're going to move on and plug in 2 in the formula. We're going to continue with 3, 4, 5, and 6 until we have computed all the terms, the first 6 terms in the sequence. With all 6 terms calculated, we're going to go ahead and write these terms as a sequence. I'm going to write them in set notation. I'll put in my 6 terms, and I'm going to end it with ... which means and so on. Good job. Alright, our second example. Again, I'm going to plug in for n, substitute for the value n. So n equals 1, n equals 2, n equals 3, and that's going to generate the sequence of terms. And then I'm going to write the sequence as a set. And so on. And that's our answer. Okay, next 2 examples we're going to speed up a bit. There's a lot of calculation that goes on, but it's still simple. We just plug in for the value for n to find the terms in the sequence, finding the first 6 terms, and then write them as a sequence, write them as an ordered list or a set. Oh, I forgot the ... which means and so on. Okay, now you're going to do problems number 8 through 14. I've got them shown here, but they'll come again at the end of the video. On to the next examples, number 25 through 31. Here we want to write an explicit formula for each sequence and then find the 10th term. That means that we're going to analyze the sequence to determine the pattern. Then we're going to write the formula for the nth term, and then we're going to use the formula to find the 10th term. We're going to plug in n equals 10. So you're going to use that process, and your work is going to show the work that shows the pattern. You're going to write the explicit formula for the sequence, and you're going to find the 10th term. Let's see some examples. An explicit formula for each sequence. Okay, so I see that each term is 3 more than the term before it. So that means we're just adding 3. That's a common difference of 3. That makes this an arithmetic sequence. The first term is 3 plus 1. The second is 6 plus 1. The third is 9 plus 1. So our pattern then is 3 times n plus 1. Okay. We also need to say, though, that we're going to start at n is equal to 1, and we're going to use all the numbers greater than that. So n is greater than or equal to 1. We're stating essentially the domain. Okay. So the 10th term is going to be 3 times 10 plus 1. That's 31. And that's our answer. Alright, it seems pretty obvious that here we're dealing with an arithmetic sequence with a common difference of 1/2. We're adding 1/2 each time. So we'd say the common difference is 1/2. When we write this pattern, we're going to have 1/2 plus 1/2 times n, and then we're adding how much? We're subtracting 3 each time. So we start at 1/2 minus 3 is negative 2.5. And we're going to start for an n value of 1 and count up from there. So our 10th term is going to be 1/2 times 10 minus 3. We just do the arithmetic and find that the 10th term is 2. Okay, we're going to see that we don't have a common difference because we're adding 2 more each step. So it's not arithmetic. It's also not geometric, but there is a pattern to it. Okay, let's look at the first term, and we see that we get 2 is 1 squared plus 1, 5 is 2 squared plus 1, 10 is 3 squared plus 1, and so on. So our pattern is n squared plus 1, starting at n equals 1. The 10th term then is 10 squared plus 1 is 101. Okay, so not arithmetic. This actually looks like a geometric sequence, because each time we're tripling. Let's check the ratios then. We see each term is 3 times the term before it, so we have a common ratio of 3. Okay, so our pattern was 3 to the n minus 1, so that 3 to the 0 is 1. That was our first term. Alright, so the homework problems, number 24 through 32 even. Again, these will be at the end. And move on to examples 33 through 41. For the find the 8th term of each sequence. Okay, in order to do that, first we have to find the pattern. Then we're going to have to write an explicit formula for the sequence. And so finally then we can evaluate the formula for n equals 8. So we're going to compose an explicit formula and use that to find the 8th term. Your work should look like the work, the explicit sequence, and the 8th term in the pattern. Okay, find the 8th term of each sequence. This is obviously an arithmetic sequence where we're just adding 1 each time. So d is equal to 1. Okay, that means we're going to have that the nth term is equal to minus 3 plus n starts us with negative 2. Then we do a little bit of algebra to find n minus 3. And that way our first term is negative 2, our second term is negative 1, and so on. And we need to state our domain n greater than or equal to 1. So the 8th term is just 8 minus 3 equals 5. Okay, this looks like we're halving each time. So 20 is half 40, 10 is half of 20, 5 is half of 10. So we have a common ratio of 1/2, and it's a geometric sequence. So we're going to start with 40, and then we're going to multiply by 1/2 and raise to the power n minus 1. So when n equals 1, we have 1/2 0, and that means the first term will be 40. The 10th term is going to be 40 times 1/2 to the 9th, or 7th power is 1 over 128. We get 5/16. Okay, this term, obviously not arithmetic. This sequence, not arithmetic. And but when we check to see if it's got a common ratio, we see that each of these, each term is 1/4 of the term before it. So our common ratio is 1/4. So we're going to start with the lead term. Start with 144. And then we're going to multiply by 1/4 raised to the n minus 1 power, which I have to write in there still. And we're starting at n greater than or equal to 1. Okay, so our 8th term, we raise 1/4 to the 7th power, and we end up with 144 divided by, I had to use the calculator here, And it's a great big ugly fraction right here. Okay, so we can work this out with the calculator and get a decimal answer. But I really don't like seeing decimal answers. I'd rather see a fraction. Okay, so in order to work the fraction out, we got to find the common factors of 144 and the denominator. So we work out the factors for 144 and see which one of them divides 16,384 without a remainder. And then we're going to divide both 144 and 16,384 by 16. That gives us a nice, neat fraction to work on. We get 9 over 1024. I much prefer seeing an answer like that. All right, this sequence is not arithmetic. We see that each successive step we're subtracting more and more. But again, look at the difference from 2. Okay, first is 2 minus 0, the second is 2 minus 1, the third is 2 minus 4, 2 minus 9, 2 minus 16. You should see the pattern of squares there. Okay, so 2 minus n minus 1 squared is the pattern we get. But that's not necessarily the way I want to write it. I'd rather start with that n term first. So n minus 1 squared plus 2, and then state the domain starting at 1. I did forget a minus sign though. It becomes pretty obvious when I try to work it out here because I get 49 and then I'm going to add, and that doesn't fit the pattern. I should have a negative number. I forgot my minus sign. So I'm going to add my minus signs through. Now I get negative 47 is the 8th term in the sequence. Got to check. Okay, there's a flip-flop pattern where it goes positive, negative, positive, negative. And whenever you see that, you need to recognize that what you're doing is squaring, cubing a negative number. Okay,